Hello friends, in this lecture we are going to discuss about reactions of furan. So specifically we'll see reactions of furan with electrophilic reagents. Reactions with electrophilic reagents. So furan is pi excessive heterocycle and exhibit greater reactivity towards electrophilic substitutions. As far as the comparison of reactivity is concerned, furan lies between pyrrole and thiophene. Okay, so furan, you have to know that it lies between pyrrole and thiophene. It is less reactive than pyrrole. Okay, so furan is less reactive than pyrrole but more reactive than thiophene. Very important point. And it is pi excessive heterocycle. That's why it has greater reactivity towards electrophilic substitutions. The lower reactivity of furan than pyrrole is because the oxygen atom accommodates positive charge less readily than the nitrogen atom, while the higher reactivity of furan than thiophene can be attributed to the smaller orientation effect of sulfur than that of oxygen. Furan undergo electrophilic substitution reaction preferentially at C2 and C5. In previous lecture, we have seen that C2 and C5 are alpha and alpha dash positions. That is, furan undergo electrophilic substitution reactions at alpha position. So alpha substitutions are possible, and these positions are comparatively 6 into 10⁻11 times more reactive than a benzene position. If these positions, that is C2 and C5, are occupied, the substitution takes place at C3 and C4. If and only the C2 and C5 positions are occupied, then and then only the substitution takes place at C3 and C4 positions, that are beta substituting positions. And these positions are also even more reactive than position of benzene. The preferential electrophilic substitution at C2 and C5 positions, that is alpha substitution, is attributed to the resonance stabilization of the transition state and resulting from the attack of electrophile at alpha position and the powerful orientation effect of the ring oxygen. So C2 and C5 are the very important positions for furan, at which electrophilic substitution reactions preferentially occurs. So this is an electrophilic attack. Okay, so electrophilic substitution reactions preferentially takes place at C2 and C5. So this is an alpha substitution and this one is an beta substitution. So first reaction is nitration. Furan is nitrated with mild nitrating agent acetyl nitrate at low temperature. So acetyl nitrate is an reagent condition. The reaction proceeds by an addition-elimination mechanism involving an intermediate 2,5 addition product. So this reaction gives 2,5 addition product as an intermediate product. Okay, and then further it gives nitrated furan at second position. So in presence of this mild nitrating agent, that is acetyl nitrate, so this structure is for acetyl nitrate. It gives or it donates its NO2 to furan, and the substitution takes place at second position, that is alpha position. Similarly, this is an CH3C double bond CO NO2, that is acetyl nitrate. So this is a detailed mechanism. In presence of fuming HNO3, this group attached at second and fifth position, and then further it gives NO2 substitution at fifth position. Whenever there is a second position is occupied, then the substitution takes place at fifth position. So this is an example for this point. Then sulfonation. Furan is sulfonated with the complex of sulfur trioxide with pyridine or dioxane and provides 2-sulfonic acid or 2,5-disulfonic acid depending on the reaction condition. So this furan is sulfonated at second and fifth position. It gives disulfonated product. It is 2-sulfonic or 2,5-disulfonic acid. So this is a very important sulfonating agent. With pyridine. Then bromination reaction. The reaction of furan with bromine in carbon disulfide at minus 50 degrees Celsius 2,5-dibromo 2,5-dibromo furan. Each outcome produces 2-bromo furan. Reaction is considered to proceed by an addition-elimination mechanism. So due to the presence of this Br2, it attacks at furan at second position in presence of this CS2 at minus 50 degrees Celsius. Then it gives cis plus transform. Okay, and then further in warm condition, in presence of warm condition with the removal of one hydrogen bromide group, it gives furan substituted at second position with bromine. That is 2-bromo furan. So this all reaction, that is bromination reactions, takes place at second position. And if second and fifth position is occupied with some substituent, then the reaction takes place at third and fourth position. But the bromination of furan is in methanol at minus 10 degrees Celsius in the presence of base provides 2,5-dimethoxy 2,5-dibromo furan. 2,5-dimethoxy 2,5-dihydrofuran involving an attack of nucleophile on the cations rather than an elimination of proton. So this is a somewhat different reaction from the reaction which we have previously seen. So this Br2 first attacks at second position in presence of CH3OH and minus 10 degrees Celsius, that is methanol at minus 10 degrees Celsius. Then in presence of this methanol, it attacks at fifth position. Then further there is a removal of bromine from second position, and then further in presence of this CH3OH group, it uses furan substituted with OC. Finally, we get the furan substituted at second and fifth position with methoxy group. Then bromination of furan substituted with an electron withdrawing substituent at position 2 generally provides 5-bromo derivative involving an electrophilic substitution mechanism. In this case, the second position is occupied with this electron withdrawing substituent. Then bromination takes place at fifth position. Similarly, in this case also, the second position is substituted. And these are the important conditions which are very important for the reaction to proceed. Then chlorination. Chlorination of furan with chlorine in presence of dichloromethane at minus 40 degrees Celsius provides 2-chlorofuran as a major product. So this is in scheme 146. If the electron withdrawing group is present at position 2, only 5-chloro derivative is obtained. So there is in presence of this chlorine group, it attacks at second position on furan in presence of this Cl2 at minus 40 degrees Celsius and it gives mixture of product. So there is a possibility to attack of chlorine in second position as well as fourth position and fifth position, but yield is different. The 2-chlorofuran produced with high yield, that is 64%. Similarly, if this position is occupied with some substituent or different group, then chlorination takes place at acylation of furan. The acylation of furan with acid anhydride in presence of mild catalysts such as phosphoric acid or boron trifluoride etherate results in exclusively 2-acyl furan. The acylation of furans can be performed also with acetyl paratoluene sulfonates or Ac2O SnCl4, that is stannous chloride. Although trifluoroacetic anhydride does not require any catalyst. So this is an acylation reaction of furan. So this acyl group attacks at second position in presence of the reagent, that is H3PO4 BF3 diethyl oxide. Okay, so from this reagent condition, what acyl group at second position? Then alkylation. Furan does not undergo Friedel-Crafts alkylation. Catalyst required in Friedel-Crafts alkylation affect polymerization because of the acid sensitivity of furan. The alkylation is affected by alkenes at the position 2 in the presence of mild catalyst, this phosphoric acid or boron trifluoride. So this is an alkylating agent. Okay, in presence of H3PO4, the furan is alkylated. So this R is for any alkene. Based on the whatever R group you are taking in reagent condition, you will get the product. The reaction of furan with isobutene and phosphoric acid results in the mixture of 2 and 3 alkylated, that is tertiary butylation of furans. This is a tertiary butylation of furan. Tertiary butyl group attacks at second and third position. So there are possibility to get two different product in the reaction mixture. Reactions with diazonium salts. Furan undergoes phenylation rather than diazocoupling on reaction with benzene diazonium salt. So this is in the reaction of furan with benzene diazonium salt. So in presence of NaOH, there is a attachment of C6H5 at second position on furan. So this is a reaction known as an phenylation reaction of furan. So phenylation rather than diazocoupling. So furan undergo phenylation reaction rather than diazocoupling is a very important point. Then nucleophilic substitution reactions. The nucleophilic substitution reactions involving substitutions of the halogen atom from the position 3 are rare, but 3-methoxyfuran is obtained by the reaction of 3-iodofuran with methanolic sodium methoxide in presence of copper 2 oxide. So this is an copper oxide. Okay, so there is a replacement of iodine with methoxy group in presence of this CH3ONa. Okay, that is methoxide, sodium methoxide. So iodine is replaced with methoxy group, which is an nucleophilic substitution reaction. Thank you.